Hello everyone. So today we are going to cover about the general science section of the general awareness. Okay, so let's start. So basically the general science section covers up to class 10 syllabus of science. Class 10 syllabus of science. Okay, the science which you had studied up to your class 10 will be covered under the general science section. And general science section is divided into three parts: A, B and C. A part stands for physics, B part stands for chemistry, C part stands for biology. Okay, so these three parts combined together form the general science section. Form the general science section. Got it? So we are going to study about general science in the same format, like starting with the physics, then we will cover about the chemistry, then we will cover about the biological part or biology part. Got it? And the topics which we will cover, like the study of forces, motion, energy, matter, chemical reactions, human body and natural processes. Got it? So let's start. So first is a physics, as I have told you, and in physics we have Newton's law of motions basically. Okay, so basically motion is a movement of things, of person, of individuals, comprising walking, rolling, skipping, gliding, driving, running. So these all are a part of the motion. Means when the things are in motion or things are in movement, basically, not motion exactly. When things are in movement, then these covers the part of the motion. Okay, and the laws of motion covers certain basic fundamental principles behind these motions. Okay, so starting with the first law of motion. So Newton's first law of motion basically states that an object at rest wants to stay at rest, an object in motion wants to keep moving unless something pushes or pulls it. Okay, so basically you can say if a person is in motion and if a person is at rest, so they both will not change their state of motion, whether it's in moving, whether it's in movement, whether it is moving, or whether it is resting. So they will not change their state until or unless something forces them. For this moving, something requires to stop him, and for this resting, someone is required to start him or moving a little bit. Okay, so this is the first law of motion basically. Okay, and the first law of motion is also comprise the inertia. The inertia. What do you mean by inertia? Inertia is basically physical force that keeps things in motion or resting. Okay, so basically inertia is a physical force that keeps things in motion or resting. Okay, and basically you can say it is a force which maintains the state of an object. Got it? For example, let's suppose he is the person who is sitting on the bus seat. Okay, on the bus seat, he is sitting. It is a bus. Okay. He is sitting. And whenever you have also seated in the bus, you notice one thing. When the bus stops, you bend forward. And when bus start, you move. When bus start, you move backward. Okay. So whenever the bus suddenly stop, you always move forward. And whenever the bus starts, you always move backward. This is because of the inertia. Because your upper body is not in contact with the bus movement, but your lower body is in contact with the bus movement. Got it? So when the bus gets stopped, your lower body gets stopped, but your upper body is still in a motion. So you move forward. But when the bus starts, your lower body is in contact with the bus, so your lower body starts to moving forward, but your upper body, which is not in the contact with the bus, is still at rest, so that's why you move backward. Got it? So now let's take another example of this Newton's first law of motion. Suppose you have a toy car on the floor. If you don't push it, it will just stay there. This is your toy car. Okay. So if you're not pushing it, it will be a stay. Okay. But when you push it, it will be moving. It will be moving because some external force applied because of pushing. Got it? So it changes resting position into movement. But remember one thing. This external force is in the constant form. Should be in the constant form. Otherwise, the object will be stay as it was. Okay. So this car was in the resting position. When you push it, it started moving. But if your force is not in a constant manner, then this car will stop eventually. Okay. So remember this thing, that force should be in a constant manner. Got it? Now come to the second law of motion. So Newton's second law of motion. Basically, this second law of motion, clearly state that movement or momentum of a body is equal to applied force. So basically the Newton's second law of motion says that the amount of force you applied on an object will be the amount of momentum which you will get as a result. Okay, so let's take an example to understand it. Suppose this is a car, toy car basically. This is a toy car. Okay, if I pushed it, it will be start moving. Okay, it will be start moving. Because some external force applied on it. Got it? But how much it will move? That's a question in the second law of motion. Okay, so let's suppose there are two conditions, condition 1 and condition 2. One condition, low force, or you can say less force is applied on a car, then the car start moving from this to this only. Okay, in second condition, more force is applied, then the car moves from this to this direction. So in which scenario the car covers the large distance? Obviously in the second case, because this is the case of the second law of motion. The momentum of body is equal to the applied force. In that case, we applied a less force, the movement will be less. In this case, we applied the more force, the movement will be more. Got it? And also here you can see, the harder you push an object, the faster it will move. Okay? And for this, we have a formula which is F is equal to M point A. F is equal to M point A, where F stands for force applied, M stands for momentum, and E stands for acceleration. Okay, so this is the formula of Newton's second law of motion. Got it? Now, let's come to the example. Think of two cars, one is big and heavy and other is small and light. If you push them both with the same force, the lighter car will move faster than the heavier one. But if you push the big heavy car with a lot of force, it will move faster than the small car. So example is very much similar to the example which we have taken just now. Suppose this is one car. This is one car of 2 kg. This is one car of 250 grams. Okay. So this car is lighter, whereas this car is heavier. Okay. And always remember, the heavier the object, the harder it is moved, because you have to apply more force in comparison the lower, or you can say the lighter object. Okay. So to move the car with 2 kg weight, we required a more force in comparison of to move the car of 250 grams. Got it? So when you push them, car A which is the heavier one and car B which is the lighter one. When you push both of them, the heavier car just move this much, whereas the lighter car move this much, because the force applied on the lighter car is less than the force applied on the heavier car. But the momentum acceleration of the lighter car is more than the heavier car. Got it? But if you want to move this car as in speed of the lighter car, then you have to apply more force on the heavier one to get the momentum like the lighter one. Got it? So this is the second law of motion. Okay. So now let's come to the third law of motion. Newton's third law of motion. Basically, it means that every action there is an equal and opposite reaction. Okay. So whatever you have done, you will get the same result. Okay. Let's suppose if this is a person and this is a wall. Okay. He started running towards the ball and thereafter he hit the wall. Okay. And the measurement unit of force is Newton. Just take an example. So, okay. So he hit the wall with 10 Newton or with the force of 10 Newton. Okay. So 10 Newton was his force with which he hit the wall because our equation says there is an equal and opposite reaction. So the ball will also hit him with 10 Newton of force. The same force will be hitting him back as the force he applied on the ball. So this is the third law of motion. Got it? Also, we can take an example. If you ever have been to the swimming pool, then you must remember, like this is a water surface of swimming pool, and this is a stand above it. Okay, and this is a person. Maybe it was you when you were in the swimming pools. Okay, so people generally come to the top of this stand and they usually jump to the water. Okay, so whenever you jump to the water, then you must remember that your body gets some red spots. Your body gets some red spots once you jump from this platform to this water, because whenever you jumping from this height to the water, you always apply some force on water surface. On water surface whenever you're jumping. Okay, and because when you applying force to the water surface will also give force shock to you. Okay, so just take an example. Suppose this person apply a force of 20 Newton. So with the force of 20 Newton, he jumped from the platform to the water surface. And when he will hit the water surface, the water surface will also apply 20 Newton force to him. Okay, because for every action there is an equal and opposite reaction. Okay, so now come to our next point. So now let's come to some more example. Okay, so this example, suppose you are sitting on a chair. When you sit down, your body pushes the chair down. At the same time, the chair pushes you up with an equal force. So you don't fall through the chair. This happens because every time you push something, it pushes you back in the opposite direction. So let's understand this example or convert this example in a action. Suppose this is a chair. This is a chair. Okay. That is the person. If this person will sit on this chair, okay, when this person will sit on this chair, then he will apply the force towards the downward direction. Okay. So why don't he fall down? Because when you're sitting on the chair, you are going downward because you're applying a force in the downward direction. So why you don't get fall down? Because when he will start pushing the chair down, the chair will start pushing him up. Suppose he is applying the force of 4 Newton. Just an example. He is applying force of 4 Newton in the downward direction. Okay. So similarly, the chair will apply a force of 4 Newton to push him upward. Okay. So both downward as well as upward force will get equalized and that person will not fall down. Got it? So this is about the Newton's law of motion. Got it? So these laws, basically, why these are called Newton's law of motion? Basically, the question is this. Why these laws are called Newton's law of motion? Because there was a person whose name was Sir Isaac Newton, a famous scientist who found these laws. So these laws are known as Newton's law of motion. Got it? And these laws are responsible for various movements which we see today around us. Got it? After finishing the laws of motion, let's understand some of the related topics which are important for better understanding of the motion phenomena. Got it? The first is conservation laws, and the first law is conservation of momentum. So basically, the first question is, what do you mean by the conservation? First question is, what do you mean by the conservation? The conservation basically means keeping the thing as it was. As it was. So basically, the conservation means keeping the things as it was, not increasing, not decreasing, not increasing, not decreasing, or keeping the thing as it was. Okay, so this is the basic meaning of conservations. Got it? So let's take an example for conservation so that we can understand the concept better. Suppose if this is a jar which I have, and this jar is full of 10 coins. This jar is full of 10 coins, or basically instead of coins you can say 10 units of something, whatever the things will be, but 10 units of something. Okay, I told you just keep this jar as it was. Okay, so when I will ask you to return this jar unit should not be 8 units or 9 units, means there should be no decreasing in the quantity, and their unit should not be 11 units or 12 units, means there should be no increasing. There should be no increasing in the quantity. So if I get the jar in return as I had given to you in the earliest form, then it will say it's the conservation. But if any of such case, whether it goes down and whether it goes up, in such scenario, this will not be a conservation. Got it? So basically, in conservation laws, we are going to study about the conservation of different things. Like the first is the conservation of momentum. The conservation of momentum. Okay? So basically, the momentum is total motion kept in an object. Okay, suppose if I ask you about this object and I ask you how much this object can move. Okay, so you can find it out through the momentum. So momentum is basically the total motion kept in an object. Got it? So the conservation of momentum is a principle which states that in the absence of external forces, the total linear momentum of a closed system remains constant, maintaining its magnitude and direction. Let's suppose if this is an object and this total momentum is 10. Just an example. Okay? And no force is applying on it. No force is applying on it. No force is applying on it. Then the total momentum will be 10 in the conserved form. But if some force is applied on it, then it may be increased up to 12 or 15 or whatever it may be. Okay? Because now there's some external forces applying. Some external forces applying on it. Got it? So this is the basic statement of the conservation of momentum. Basically means if no force is applying on an object, then the total momentum of the object will remain same. But when the force is applied on the object, then the total momentum of the object will be changed as per the force applied on it. Got it? So let's take an example. When you kick a soccer ball, it starts moving because your kick gives it momentum. Now when you see the ball rolling on the ground, it doesn't stop by itself. That's because the momentum you gave it wants to keep it moving. So the ball's special power momentum makes it go for a longer time. Okay. So let's convert this example into action. Suppose this is a ball, and if you kicked it, before you kicking it, it was at rest. It was at rest. But when you kick it, it will start moving. First it was there, second it was there, third it was there, fourth it was there. So it is continuously moving when you kicked it, because at first there was no force applying on it, so it was at rest. But once you applied a force on it, it will start moving. Okay, and it will move till it was stopped by some external force also. Got it? So it was a conservation of momentum. Now second is conservation of energy. Basically energy is a power of doing work. Basically energy is a power of doing work. Got it? So the conservation of energy is the fundamental principle that states the total energy in a closed system remains constant over time, with energy transforming between different forms but never being created or destroyed. Got it? So let's take an example. Suppose if this is a jar where there are three forms of energy: first form, second form, and third form. Each energy stands for 10, 10, and 10. Total this energy comprise 30. Okay. So the total energy of this jar will remain same in every condition, but energy could be transformed. It could not be created nor be destroyed, but it could be transformed. So at first every energy has 10 units, but as they transfer due to some chemical reactions 1, 2 and 3, this energy remain 5, this become 15, and this become 10. So is there any change in the total valuation? So the answer is no change, because before the reactions or the transformation the total energy was 30, and after the reactions and the transformation still the total energy is 30. Got it? So the conservation of energy state that in the closed system energy remains same. It could not be created nor be destroyed, but it could be transferred only, as we have discussed in this example, that the total energy count was 30 for 1, 2, 3 energies with 10, 10 units each. But after the reaction the energies got changed. First energy was 5, second energy was 15, third energy was 10, but the total count was still 30 because energy 1 got transferred into energy 2, but it was not created and not destroyed. Got it? So just take an example. Imagine you have a toy car on a slope. You let it go. It starts moving faster and faster. Where does this energy come from? When the car is higher on the slope, it has more energy. As it goes down, energy changes into the energy of motion, making the car go faster. The energy doesn't appear, it changes to make the car move. Basically there are two forms of energy: kinetic and potential. Basically the kinetic is related with the motion. It comes with the motion of object, whereas the potential is come from the position of an object at height or due to stretch. Okay, so potential energy comes from the position of an object if the object is at height or if the object is get stretched. Okay, whereas the kinetic energy comes from the motion of an object. Okay, so in this example, there was a slope where the car was placed. Okay, so at that time it was at higher position, so it was the potential energy. But when the car start moving down, so for movement it required some energy to perform this movement. And this movement is coming from the kinetic energy, because the kinetic energy providing it the power to move down, and here the potential energy is getting converted into the kinetic energy. Got it? So here we have finished about the conservation of the laws. In this chapter we covered the first basic introduction of the physics. In our next lecture we will discuss about the thermodynamics concept. Till then, thank you.